Rahim, welcome back to my channel. I'm back with a video on DES, Data Encryption Standard. Last video was on how you're going to encrypt, what is the encryption process, how you're going to go from plain text to ciphertext. And we went through a spreadsheet. As you can clearly see, this is the spreadsheet I was using. I also shared a link to this spreadsheet and the other spreadsheet. So if you were to look closely on my spreadsheet, the left-hand side of my spreadsheet, on my left-hand side, it was actually explaining the encryption process, and the right-hand side is actually a key generation process. So we're going to look at, in this video, we're going to look at a key generation process. What a key generation process for any block cipher is that from a key, from one major key, like let's say this is the key, from that, for every single round, you will get an individual key for that particular round. So for example, in DES, we have 16 rounds. So for DES, we'll get 16 individual keys from this main key. Those are called round keys. So there is an algorithm which is involved, and so we're going to look at that. And this is based on this. I'm going to simply zoom it out. So this is that algorithm, sort of like an algorithm, and how does these bits will go by. So the actual key size is 56 bit. This is the master key size. The one key, out of those one key, we're going to make 16 individual round keys, and every single round key is going to be 48 bits long. All right. But as you can see in my graph, or in this diagram, there is a thing called key with parity bits. So basically, we're taking 64 bits, and then we're passing it through something called a parity drop box, which looks something like this, which is doing nothing but just mixing the rearranging the position of your bits. And after this parity drop box, you have 56 bit of key. You don't need to have this parity drop box. This is some additional stuff they just put in. I found it in a book, so I just included it. If you can just simply take one master key of 56 bit, and out of those 56 bit master keys, you're gonna have 16 individual round keys which are 48 bit long. Alright, what is the purpose of these parity drop box? Think of it like parity as an error correction scheme, or sort of like an error detection scheme. So it allows me sort of like an error detection. So if there is an error in terms of bits, you will still have 56 bits to manage with. But the idea is exactly the same. It's just a parity drop box for rearranging and sort of like compressing it from 64 bit to 56 bit. But in the standard, the original key, master key, should be a size of 56 bit. Based on these 56 bits, we're going to run this algorithm. So the first thing I need to do, let me just go with the diagram that I have. This is how I actually did it in my Excel sheet. So just quickly look at it. So, okay, now let me go to my sheet. So if you were to look at it, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 16 hexadecimal numbers. One hexadecimal number equals to 4 bits. So 16 times 4 would give me 64 bits. So the first thing I have done, just like I've been doing it on my encryption process, is to convert those hexadecimal bits into something called hexadecimal number into bits. And they are like positioned from 1 to 4 and stuff like that. Same thing I've done it on my key generation algorithm. So the first thing I've done, I've taken my 64 bits and I just label them from 1 to 4. So bit number 1, 2, 3, 4, 5, 6, and so on, all the way up to 64. And I've called it that I'm converting my key into bits. All right, that's the first thing I'm doing. So just to give you an idea, so the first letter of my key is A. So A is normally 10 in decimal numbers. So if you convert 10 into binary, that would turn out to be 1010. Second character or second hexadecimal number is also A. A is 10 in decimal number, so 1010. The second number is B. B is 11, so 1011, 1011. So far, the first row is actually nothing but the conversion of my bits, my actual key, 64-bit key, into from hexadecimal to binary. Now the second block that you see is actually after parity drop box. Now out of parity drop box, which means your 64 bits will shrink down to 56 bits. So for that, what do I need to do? This is a key generation algorithm. So I'm going to go to my box. So this is the parity. So this is basically tell me how you're going to rearrange your bits. So your first bit is going to be your 57th bit. So let's navigate through our 57th bit, which is, so this is 1 to 4, 9, 12, all the way. So this is my 57th bit. This is going to be my first bit. So I'm going to move this right here. All right, so this is my 57th bit. So I just simply move down here. So this is, I'm going through a block called parity drop box. All right. Now, my second bit is going to be, the second bit is going to be my 49th bit. So what is my 49th bit here, or bit here, is 1. So I'm just simply moving this, changing its position to 2. Now my third bit is going to be my, whichever was at position 41 on my initial, after I converted. So my 41th bit is 0. So I'm just going to simply move here. Now let's look at one more time. Now my fourth bit is going to be my 33rd bit. So my 33rd bit is actually 0, and that is becoming my 4th bit. Hence, this is how you're rearranging it. So now from 64 bit after parity drop box, this is actually going to be your master key. These 56 bits are going to be your master key. From these 56 bits, I'm going to create in 16 individual keys, and every individual key will have a size of 48 bits. All right. So what is the first thing that you see in your diagram? All right. So what I'm going to do is this. Now the idea is simple. These 56 bits are going in. They are being split into 28 bits on your right hand side, 28 bits on your left hand side. All right. This is what the diagram is saying. These 56 bits are coming in. The right hand bits, the right hand 28 bits is starting from 56 to whatever that number is, and 1 to 28 bit. So that left hand bits are called left hand bits, and right hand bits are called right hand bits. Let's quickly look at that. So right here. So basically what I'm saying is this: all the way bits from 1 to 28. All right, let me just highlight them. So these are, I'm calling them my left hand bits. Now these bits all the way up to 56, I am just going to give them a color. I'm going to say they are, let me just do some neon color. They are green. So this is going to be my right, these are going to be my right hand bits, and these are going to be my left hand bits. Now, what is the second step that I need to do? I need to shift left. So, which means I need to shift my right hand bits. How many bits do I need to shift? And I also need to shift my left hand bits, and I have to left shift them. So around 1, 2, 9, 16, you're going to shift only 1 bit. And while the other round, which means 3, 4, 6, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, I need to shift 2 bits on my left hand side. So since I am going through, this is round number 1, I'm just going to simply go here and I'm going to shift them. So I need to shift my right bits 1 bit, and then I need to shift these bits 1 bit. Alright, so I'm going to do this. So now this is what I'm going to do. So these are my right hand bits. So now if I move this like this, sorry, if I were to, I don't know if you will be able to see my action that what I'm trying to do. So if you were to shift this on your left hand side, if you were to shift this bit on your left hand side, what will happen to this bit? This bit will move, it will go around, it's going to be a circular bit, and it will become a last bit after 0, isn't it? When I shift a single bit, it's going to be a left shift. So I'm going to shift this bit out. So this bit will come out, this will go around, and it will become the last bit after this 0. After this 0, which is highlighted in yellow. And look at it. And once I did that, once I shift this right here, so the last 2 bits are going to be 0, 1. And my first 4 bits are going to be 1, 0, 0, 0. 1, 0, 0, 0. Let's do it one more time. What do I mean by when I'm shifting a single bit? I'm saying is this last bit, the first most significant bit, is going to come out from here, and it will go after this 0, which is the least significant bit on my left hand side. So it will go after this 0. All right, hence you will get this. So basically you're shifting a single bit. Now I'm going to do exactly the same process on these bits. Now these bits are my right hand bits. How many bits do I need to shift as per my diagram? 1 bit. I'm going to go ahead and I'm going to push this bit out. So I'm going to push these bit out. This bit will come out. This 0 will go and go like this in a circular manner, and it will become the last bit. So the last bit's going to be 0, 1, 0, 0. The last 4 bits are going to be what? 0, 1, 0, 0. And once this bit is out, so now your next the 4 bits are going to be 0, 1, 1, 0. I hope you're understanding this. So in this way, you will have this process which you just took care of. Now what do you need to do? You need to take these 56 bits into something called a compression P box. What is a compression P box? Is nothing but that is given in a standard. Is just a way to mixing or rearranging the bits. That's all you're doing. Rearranging the bits, nothing else. So once you rearrange your bits, so now we're going to do this operation here. Because in my spreadsheet, this is the data after you shift 1 bit. So now after compression, so compression bits will be done on these bits. So your first bit, as per our diagram, is going to be a 14th bit. So in my original data, I'm going to go to my 14th bit. So this is 12, 13, 14. This would become my first bit after compression P box. So this is 0. Now your second bit is actually your 17th bit. So your second bit, this bit should be coming from 17th. So this is 16, 17, 0. Let's look at it one more time. Let's look at your third bit is going to be your 11th bit. So my 11th bit is 9, 10, 11. So this is 0 right here. Your fourth bit is going to be a 24th bit on my original data set, which is coming from here. So 1, 2, 3, 4. This is 24, and that is 1. And this is how these things will get populated. Now, if you were to look at it, let me just quickly go ahead and look at it. Now, this, whatever is going to come out from your compression box, that is going to be your round key. So since this is round number 1, so round number 1 is going to be consisting of 48 bits. And all the round keys are 48 bits. These are the 48 bits which you should see. So let's look at it in our spreadsheet. So if you were to just look at it, if you were to just simply look at it, now just converting this, I haven't done that step. There was a reason for it, but I'm just going to show you in my other spreadsheet. Is that, okay, what is this? So the round key should be, so this, when you convert this binary into decimal, so this is just 1. If you were to look at it, this is 8 plus 1 is 9. All right. Now 4, so this is going to be 4. And this is going to be 8 plus 4 is 12. So 12 in hexadecimal is going to be A is 9, 11 is B. So it's going to be around C. I hope you're understanding it, what I'm trying to do here. I'm just simply converting these bits into your hexadecimal number, into hexadecimal number. So I can show you, indeed, it is a key after each round. So this is our key. I'm going to simply copy my key. Let's just copy it. And I'm going to go to my different spreadsheet where I have individually calculated all of that stuff right here. I'm just going to simply plug in my key here. I think it's already there. Command C. I'm just going to hold on a second. I'm going to copy this for you. Copy this one. So this was my key I was working with all the time. Paste. Alright, so it's pasted. Now let's look at our round key. So this is my round number 1 key. Round 1 key. 194 CD. Let's look at our spreadsheet now. 194C. Let's look at the second one. So this is C. So C, this is including 1. This is going to be D. and this is indeed D. This one is all 0. This is what I expect to see. Hence, you will see a round key generation, which is taking place by just simply changing the key. If you were to look at it, by simply changing the key, let's just simply change the key. Let's change this to F. Now you can see the round key changes a little bit, not a whole lot, but a little bit. But the key thing that you need to remember about this is that your right hand keys, so only 30, when you're encrypting your data, only 32 bits are being encrypted at a time, not the whole thing in one round. So this is a small tutorial on how you're going to actually do a key generation process, and I'm going to leave a link to these spreadsheet which I just made, which I made a long time ago. So you can go to my GitHub profile. I also have some Python code for like different things on cryptography. I have 3 repositories, so I just uploaded both of these again. So just have a look at them. If you have any questions, leave it in the comment section. Don't forget to like and subscribe to my channel.